Hello, Latin geometry students. In this assignment, we're going to talk about things that are not given. In other words, stuff that you're not going to be told, but you should know from just looking at the picture. Now, in this case, we're going to focus on 3 old rules that come up when we talk about trying to prove triangles are congruent. The 3 old rules start with this one. Remember this problem? We had this earlier in the year where we set 48 equal to 2x minus 6. Well, not worrying about the algebra, but you need to know that these 2 angles have to be congruent. When we see this in a picture where we have 2 angles across from each other like this, we know they're automatically congruent. We call those vertical angles. In a proof, if we see something like this, we can claim these angles are congruent, and our reason is vertical angles. The second old rule that we're going to use, it goes back to this picture where we had parallel lines, and if we knew the measure of one angle, we knew the measure of all 8 of these angles. We're not going to worry about all 8, but the one that comes up all the time is this one. When our lines are parallel, these 2 angles end up being congruent. These 2 angles were called alternate interior angles. So when we have parallel lines, we know that alternate interior angles are congruent. If this was in a proof, if we saw a picture that looked something like this, we could say we know these 2 angles are congruent, and our reason would be alternate interior angles. The third rule, it goes back to all these. Remember we had all these little strange rules back when we were first started talking about proofs? Well, the weirdest one, the one that was most obvious, was this. Everything is equal to itself, and that's the reflexive property. Oddly, that's the one that's going to start coming up again. Anytime we have something equal to itself, or in our case, it's going to be congruent to itself, that is the reflexive property. And in our case, it'll be the reflexive property of congruence. So if we take those old rules and mix them together with the problems we're looking at now where we have 2 triangles and we're trying to prove them congruent, these 3 pictures on the screen here represent, each one represents one of those rules. For example, in the first problem here, we're going to see 2 triangles, a triangle on the left and the triangle on the right. But this center segment, segment AD, that's a side in the triangle on the left and it's a side in the triangle on the right. So segment AD in the triangle on the left will be congruent to segment AD in the triangle on the right. It's the same segment. That'll be the reflexive property. In the middle picture here, we see that we have 2 triangles, and right in the middle, angles 2 and 3, we have vertical angles. Those 2 angles are going to be congruent. We don't have to be given that information. We know they're congruent because they're vertical angles. In the last problem there, we have these little arrows indicating that we have parallel lines. When we have parallel lines, we're going to be looking for congruent alternate interior angles. They can be a little bit trickier to spot, though. So let's take a look at the first one. If this were to show up into a proof, like we were trying to prove that triangle ABD is congruent to triangle ACD, well, we'd be given some information about some sides being congruent or some angles, but something we wouldn't be given that we would know, something else that we can add to this picture, is that we know this center segment is in both triangles. Segment AD in the triangle on the left is congruent to segment AD in the triangle on the right. We have a special symbol that we use as far as tick marks go, for a tick mark to represent something is congruent to itself. That tick mark is typically drawing a circle through that thing. Here, we're going to be able to say that this segment, it counts as a congruent segment in both of these triangles. When we get to write this as a proof, we'd have to write that information as words. The way we would do that is we would say segment AD is congruent to segment AD. Basically implied that it's the segment on the left triangle is the same as the segment in the right triangle. And we have to give a reason. Well, our reason for something to be equal or congruent to itself is the reflexive property. For the second one, we have a problem like this, and we threw in some numbers for our angles to make it easier to describe these things. In this problem, we might be trying to prove that triangle QRP is congruent to triangle STP, and we might be given that some sides or angles are congruent, but what we wouldn't be given that we would know has to be true, something we can add to this picture, is that we know angles 2 and 3 are congruent to each other. We know they're going to be congruent to each other because they're vertical angles. So how would we write that in a proof? Really simple. For our statement, we could say angle 2 is congruent to angle 3. And for our reason, we would just say vertical angles. Finally, the last one. We might be given a picture like this, and the thing that's new here is, aside from segment LK being congruent to itself, yes, that's true, but that's not what we're focused on here. We're going to make that sort of disappear. What we want to focus on in this picture is that the top line and the bottom line are parallel. That's what those arrows represent. And we have to look, whenever we see parallel lines, we have to look for what sets of angles are congruent. It can be tricky to figure out which ones it's going to be. If you have trouble with this, remember back to how we did this when we first talked about alternate interior and alternate exterior angles. We'd highlight the parallel lines, those two lines are parallel, and then look for a transversal. Which angles create alternate interior angles here? Well, it's going to be angles 1 and 4. So if we were to take that and put that into a proof, we could say angle 1 is congruent to angle 4. And our reason would be alternate interior angles. Now, before we can use this, we have to say that the lines are parallel. We have to establish that the lines are parallel because alternate interior angles are only congruent when the lines are parallel to each other. So in this case, we want to identify what we can add to this picture and then what our statement and our reason would be. Well, whenever we see two triangles sharing a side, we're going to add in this circle that states that that segment, in this case segment WZ, is congruent to itself in the two triangles. So what would our statement be? It's segment WZ is congruent to segment WZ. What's the reason for that? That's the reflexive property of congruence. All right, try another one. Here in this picture, if we were trying to prove these two triangles are congruent, there's something in the picture we can add without being told about it. What do we know is congruent? Well, we know these two angles are congruent. So what would our statement be to state that? We can say angle 1 is congruent to angle 2. What would our reason be? That is vertical angles. So let's take that new information and turn it into part of a proof. Here, we're shown this picture, and we've got a couple bits of given information, and we're being asked to prove that the two triangles shown are congruent to each other. Well, just like the other proofs, when they were really overly easy, we do the same first few steps. First thing we're going to do is take the given information and mark it in the picture. It says segment MA is congruent to segment RA, so we put little marks in the picture that represent that. It also says segment HA is congruent to segment BA. We put little marks in the picture that represent that. Now, each time we put marks in the picture, that's basically going to represent a line or two in the proof. In this case, though, that's not enough to prove these triangles are congruent, but there is something else that we know that we can add to this picture. We should also know that angles 3 and 4 are congruent to each other. And we know that because they're vertical angles. Now, if we look at this picture, these two triangles are an example of side angle side. So if we have side angle side, then we know the triangle on the left and the triangle on the right are congruent, and that's what we're trying to prove. So all we have to do is take that information and write it in the form of a proof. So first thing we do is we go to our statements, and every time we put a mark in our picture, that becomes a statement in our proof. The first thing we did in the picture is we said segment MA was congruent to segment RA. What was the reason? That was given to us. The second set of marks we put in the picture, we said that segment HA was congruent to segment BA. What was the reason for that? That was also given. Our third step, the third thing we marked in the picture, we said that angles 3 and 4 were congruent. What's the reason for that? They're vertical angles. Finally, that's all the marks in the picture. Finally, we established at the end that this is an example of side angle side, so we can say the two triangles are congruent. What would be the reason for that? It's side angle side. Two sides in the included angle congruent to two sides in the included angle mean the triangles are congruent. Okay, now we're going to try another proof. All right, same idea. Here's the picture that we're given, two triangles, where we have a little bit of given information, and we're going to be asked to prove that angle D and angle T are congruent. If you're not sure how to get to that, no problem. Let's just go through the same steps that we usually do. Step one is to take the given information and put it in the picture. We start with angle 1 is congruent to angle 2. That was given to us, so we can put those marks in the picture. That'll be a line in our proof. Statement 2, segment AD is congruent to segment AT. We put marks in the picture. That'll be a line in our proof. What else is in this problem that we know? Well, there's one more piece of information that we're not given that we do know. And that's segment AQ is congruent to segment AQ. This side in the triangle on the left is the same as this side in the triangle on the right. Then if we look at our two triangles, these are an example, again, of side angle side. So our two triangles would have to be congruent to each other. If the whole triangles are congruent, then these two corresponding angles will have to be congruent. Remember, we have a rule that says if the whole thing's congruent, then the parts in the same place are congruent. It's the rule CPCTC. So that's what we're trying to get to. So all we got to do now is take all that information and put it into a proof. So the first thing we marked in the picture, we said angle 1 is congruent to angle 2. What's the reason? That was given to us. Second piece of information, we said segment AD and segment AT are congruent. What was the reason for that? That was given to us. Statement 3, we said segment AQ is congruent to itself by the reflexive property. That was the center segment in the picture is congruent to itself. Then, once we know that, now we can say the two triangles are congruent. So we can say the triangle on the left, triangle ADQ, is congruent to the triangle on the right, triangle ATQ. Our reason for that? Side angle side. Once we know the whole triangle is congruent, now we know all the parts are the same. So since the whole triangle is congruent in line 4, now we can say that angle D and angle T are congruent. What's the reason for that? That is CP/CTC. All right, one more proof. All right, here's this proof. Now, let's start off with the same way we do the other ones, starting off with our given information. Segment AB is congruent to segment CD. We can put in marks that represent that. Now, segment AB is parallel to segment CD. So we put in a little arrow to represent that in the picture. Once we know we have parallel lines, we know that we should be looking for alternate interior angles, and angles 1 and 3 are going to be congruent to each other. Finally, one other piece of information we can be given in this picture is that that we're not given, but we know, is segment DB is congruent to itself. It's in both the triangles, so this segment will be congruent to itself. Now, if we look at this picture, we have side angle side congruent to side angle side, so we know our triangles will be congruent by side angle side. Once the whole triangles are congruent, then all the parts are congruent, including angle A and angle C. So we're going to prove that angle A and angle C are congruent. In this case, we're going to set up the proof a little bit differently. I'm going to give you all the statements and ask you to fill in the reasons. So completing this proof, our first two lines, AB congruent to CD and AB parallel to CD, those were both given to us. Why was angle 1 and angle 3 congruent? Because they were alternate interior angles. Segment BD is congruent to segment BD. Everything congruent to itself is the reflexive property. And then our triangles are congruent because of side angle side. Finally, these two angles are congruent because of CP/CTC.